All right, guys, welcome to our first lesson on what's called gas laws. So this whole unit is on gases. All right, let's get started. And there's several laws we're going to be looking at. We're going to look at an individual by the name of Boyle came up with a law in which he looked at the relationship between different factors that can affect a gas. That's what we're talking about specifically today. So this fact, the sneeze can travel up to 100 miles per hour. This message brought to you by, quote, the concerned citizens for securely fastened nose studs. Just took them out. Okay, anyways. You guys, as you can probably see here, we're going to talk about 4 factors that can affect the gas. Now you guys, this whole unit, what I want you guys to be thinking about is, when you think of a gas, just think about a sample of gas like in a balloon, right? You guys know there's gas in there, it's just air in there, okay? So you guys think about, like, what could you use to describe the air or the gas inside that balloon? You could talk about its volume. You guys, what do we always talk about? You could talk about its temperature. What else? You could also talk about the pressure that gas is exerting. You guys, whenever we're talking about gases, we're always pressure is an important factor. And then also, we can also talk about the amount of gas in that container. So those are the 4 factors. We got pressure, which we'll use big P to represent. Temperature, we'll use big T. When we talk about the amount of gas, you guys remember moles is the chemist does, and that's the number that we use that makes it easier for chemists to work with. We're going to abbreviate that with a small n, and then you also have volume, which is a big V. So you guys, what we want to try to do is try to predict what effect will one factor have on another, and that's exactly what various scientists did. The first 2 we're going to look at today, and this is what Boyle's Law pertains to, is pressure and volume. In fact, you guys, you can think about this yourself. Here, this is a relationship that Boyle came up with. Now, if you think about it, you got a balloon, and think about, okay, it's got a certain volume. What would happen if, we change the volume? Let's say we make it smaller, right? You guys notice the volume smaller. What effect do you guys think that has on pressure? As the volume gets smaller, the pressure gets, you guys might guess, just think about, how do you think I'm feeling right now as smaller volume? Look at my hands are kind of shaking. When you agree, you've taken that gas and you're putting it in a smaller volume, and when you have more collisions of that gas with the walls of the container, when you expect the pressure to increase. So that is what actually Boyle figured out, is that the pressure and volume are what's called inversely proportional. And you think about, man, that's all he had to figure out, and he got a law named after him. Well, you guys know, obviously, he carried out experiments, and he collected experimental data, numerical data, which helped confirm what we just talked about here. So look at a syringe here.
There is air inside this syringe. As the plunger is pushed in, you can feel the resistance of the gas.
Imagine pushing down on it.
When the pressure inside the syringe equals the pressure on the plunger, you won't be able to push the plunger any further.
Right. So obviously, if this is not pushing, obviously he's pushing down with his finger. If he's not pushing anymore, when you guys agree, he's exerting a pressure this way. If this is not moving, when you agree that the pressure that the gas is exerting has to be equal, right? Because if the pressure downward is equal to the pressure upward, it's not moving. So, and you guys, right, when you expect the pressure increase, now you guys got to remember this is closed at the bottom, so it's not like the gas can escape. That explains why the pressure was able to build up. So hopefully we'll be able to see now on the molecular level.
Let's look at a particle view of the gas inside the syringe.
Right, so you've got the gas molecules in there, and they're moving around randomly, and they're colliding with the walls of the container, obviously exerting a pressure. Now think about it.
Pressure is caused by the collisions of the gas particles with the sides of the container. Notice all the empty space between the particles. When the plunger is pushed in, we get a decrease in volume. There are more collisions, and the pressure increases.
So with the decrease in volume comes an increase in pressure. You know what we call that relationship? This is what Boyle figured out. Pressure and volume are what you call inversely proportional. You guys, to help us to better understand what inversely proportional, maybe that's a term that you're not too familiar with, we're going to do first an easier term. Okay, so an easier term that we could talk about first is what's called directly proportional. Okay, here would be an example of directly proportional. Let's say, for example, let's say you get an allowance. That's you. Okay, so let's say you get an allowance, and let's say every week you get an allowance. You get $20 a week. Let me see if can you guys even see this? Yeah, you guys can see it, okay? Well, let's say you have a little brother, right? Now your little brother, he's not as capable as you, he doesn't do as many chores. Hopefully if you guys get an allowance because you guys are doing chores. Let's say little bro, so we got little bro. Little bro, he only gets $10 a week. So now let's say your parents are saying, you know what, you're getting older, right? You're 16, 17, want to go out with the friends. You're like, Mom, Dad, you know, $20 a week just ain't cutting it anymore. What do you say about a raise for me? And they're like, you know, me, homie, huh, you know what, I think that makes sense, and so we're gonna give you a raise. And so then they give you $40 a week. And you know, when that happens, you know what little bro is gonna do. Little bro's like, hey, how come you get that? You know, and he's gonna be all whiny and stuff. Now, if your parents, if I was that parent, I'd slap little bro. But let's say your parents are a little bit kinder than me, and they're like, or let's say, I'd even say maybe they're weaker than me and they give in to little bro's complaints. So now if they want to be, quote, fair, okay, based on what they gave you, what do you guys think little bro should make? Well, you guys think that. I think you guys get the idea. Well, what did they do to your allowance? Didn't they double your allowance? Well, if they're going to be fair, they're going to double little bro's, and then little bro would get $20 a week. You guys, what we call this relationship between your allowance and little bro's allowance is what's called a directly proportional relationship. When one doubles, the other doubles, for example. And also, here's another way to put it, or when one triples, the other triples, or when one's cut in half, the other's cut in half. Basically, when you change one by a certain factor, if you change another by the same factor, then you would call that a directly proportional relationship. So that's directly proportional. So what do you guys think inversely proportional might mean? So that was directly proportional, okay? Inversely proportional, as you might expect, it's like the opposite. When the value of one doubles, the other is cut in half. So if one we multiply by 2, the other we divide by 2. If one triples, if one we multiply by 3, what do? The other we divide by 3. That is what Boyle found out as the relationship between pressure and volume for a gas, is that it is inversely proportional. So you guys, once again, Boyle collected data. So if you are, you guys, before this, let's go right to a graph. Typically we collect data like in a table, right? And then we translate it into a graph. We're gonna kind of go the reverse. What I want you guys to do is take a second here to think, what do you think if we plotted pressure versus volume? So just at various times we change the pressure and we see what impact it had on the volume or vice versa, and we got several data points and you plotted those. What do you guys think a graph of two factors that are inversely proportional would look like? Remember, when one increases, the other decreases, what do you guys think it would look like? Those of you guys who thought something like this, if you thought something like this, you're correct if you went down. More specifically, you know what it's gonna look like? It's gonna be curved like this. And when you guys predict that, because look, when you see like a larger volume corresponds with a lower pressure. And then you could also look here, a low volume here, you guys see it's small, corresponds to a high pressure. So this is what an inversely proportional relationship would look like on a graph. So now let's look at it with real data, because that's actually what Boyle would have used. So once again, we're comparing volume and pressure. That's what this whole thing we're looking at. Before that, when did our fridge become so eco-friendly? What do you mean? Our cheese is going green. Hopefully you guys don't have that kind of eco-friendly refrigerator. Okay, so let's look at this again. I think visuals kind of help us, right?
A decrease in the volume of a gas sample results in an increase in pressure because the gas particles will hit the walls of the container more often.
Okay, now this is what Boyle said. He said pressure and volume are inversely proportional. This is how you could write it. You guys, this would be like a mathematical representation of that. Here's how you read it. Pressure is proportional. That's a symbol of proportionality to the inverse of volume. You guys see how this is the inverse of volume, or the reciprocal of volume? It's 1 over V. That's how you would say it, okay? But once again, you guys, that is only true. You guys remember, whenever you guys are doing an experiment and you want to see what impact does one factor have on another, you have to keep all other factors constant. So this is only true if, you guys remember there was a total of 4 factors. If we keep the amount of, notice, we're keeping this constant. We're not changing the amount of gas in here. It's a closed system, and also we're not changing the temperature. This is at room temperature, about 22 degrees Celsius. I haven't changed that. Then we could say pressure and volume are inversely proportional. Here, I want you guys to notice something. Check this out. Let's try to work with some data here, okay? So let's just make this up. I'm gonna say it's not really 20 liters, but let's say my balloon is 20 liters. Oh, I don't have to put the L. You guys see, I already did it at the subject heading 20. And you guys, I bet you guys could tell me, you guys, what's the pressure of the gas inside that balloon? Well, you guys should know this. Check this out. If that balloon is not moving, you guys notice it's not moving, then what can I say about the pressure inside? When you guys agree, if the latex of the balloon is not moving, when you guys agree, the pressure inside pushing outward, wouldn't it be equal to the pressure outward pushing in, right? So when you guys agree at this point, I could say the pressure, the internal pressure is the same as the external pressure. And you guys remember, if we're under pretty much standard conditions, you guys remember from our previous unit, what is pressure of a standard atmospheric pressure? Guys, it's really easy. Remember, it's one ATM. It's really easy. That's why I always like to work with ATM. So now, check this out. Now, let's say I reduce the volume. Now I'm going to put it in half. So if I had half, it was 20 liters. Now what's the volume? It's 10. You guys, based on what we just, our understanding of inversely proportional, what would you say the pressure is? If I could stick a pressure gauge in there and measure the pressure, what would the pressure be? Well, check it out, guys. I half the volume, so what's going to happen to pressure? It's going to double. Now let's say I do it further. Let's say I'm at 10 liters. Now I'm going to go to 5 liters. Now what's the pressure? Well, I drop down to 5 liters. What's now the pressure? Look, I half that. So what am I going to do with that? Double that. Now it's 4 atmospheres. You know, you can feel it. Now let's go even further. I'm going to even half it further. So it's at 5 liters now. I brought it all the way down to 2.5 liters. You guys, what's the pressure? And I can feel it. You know, the pressure is 8. Now I'm hoping you guys would recognize something mathematically. So you guys, this is what we would expect with two factors that are inversely proportional. You know, and some of you guys are pretty good at looking at patterns and numbers. I don't know if you guys could see something really cool here. I'm hoping you guys would just pause the video and then just look at the numbers and try to find some kind of pattern. Okay, you guys, I'm going to show it to you guys right now. Check this out. Look at this. Look, if you multiply these, check it out. 20 times 1, what's that? 20. 10 times 2, what's that? 20. 5 times 4, what's that? 20. 2.5 times 8, what's that? 20. Two things that are directly proportional, their products will always equal the same value. It'll be a constant. That's what we can say here. P times V equals K. You guys, typically in science, we use K to represent a constant number that doesn't change. That's like this one right here. So this is just what's mathematically true with two factors that are inversely proportional. And what we're going to do is we're going to derive an equation that ultimately we can use to help solve gas problems. So let's say at one time, okay, so we'll just say at one time, you know, like for example here, P1, let's say it's 1 atmosphere and V1 is 20 liters, right? That would equal to a K. Well, you guys, right? We can change conditions. This was under, you know, the original condition, and then I'll change something, and then, so these values will change. We'll call that at time 2. Okay, so these would just be under different, just kind of like this. This would be time 1, time 2, time 3, time 4, whatever. Now you guys notice, you guys can actually come up with an equation. If P1 times V1 equals K, and P2 times V2 equals K, what do you guys think we can say? How can we combine those together, just mathematically? When you guys agree, can't we just say P1 times V1 equals P2 times V2 if they both equal the same thing, right? They both equal the same thing. So this is Boyles Law in its most useful problem-solving form. So you guys, we spent the last 10, 15 minutes deriving, ultimately, this equation here, and then, so we're gonna go over a problem here shortly that shows you how you can use this to get information you wouldn't otherwise have. So you guys write this down, box it out, put it in your notes. This is Boyles Law that we use when we're talking about pressure and volume. I want to remind you guys of a few things. You guys, pressure is a big thing in this unit. Here are some of the units that we should be familiar with. You remember millimeters of mercury? Remember, this is standard atmospheric pressure. This is basically what this is saying is under standard conditions, the atmosphere can support a column of mercury. You guys, 760 millimeters. This is 1,000 millimeters. 760 goes up to here. So it can support, if I had a column of mercury, that's how strong atmospheric pressure is. It's equivalent to the pressure, downward pressure exerted by the weight of 760 millimeters of mercury. Remember, there was an Italian who worked with gases named Torricelli, And so he got a unit named after him, torr. It's the same thing. So these are just interchangeable units. Once again, those are units we should be familiar with. One I like better is atmospheres. Look how much easier it is. Standard atmospheric pressure, this is a little hard to remember, right? 760 millimeters of mercury. Standard atmospheric pressure is equivalent to 1 atm. So this is the conversion factor between those two. Okay, you guys, we're going to finish with a problem. You guys write it down. It's always good to have a problem in your notes, so that way if you guys get stuck on homework, you can look back at a sample problem and see how it's done. It says, what volume would a sample of oxygen gas occupy at 2 atmospheres of pressure if 10 liters exerts a pressure of 1,140 torr? Okay. So, once again, you guys, whenever you guys are looking at a problem, I would, you know what? It always helps to.
Good morning, Spartans. This is Mr. Alcalá.
It always helps
Principal
to
here with Christian
do,
Gonzalez, who's going to lead us in the Pledge of Allegiance.
Oh, we got a pledge of allegiance here, guys. I'm recording this during the school time, so you guys have
Please stand for the Pledge of
a
Allegiance.
patriotic duty. Stand with me at home.
Ready?
My flag is right there.
Begin.
So
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
So I'm hoping you guys will be able to ignore the sound in the
Thank
background.
you, Christian. Nice
so we can
job.
Continue.
This is Mr. Alcalá again. Just wanted to welcome everybody
you know
back
what?
that's here on campus in person. We are very happy to see
Yeah,
all
we
of
just
you,
hopefully we'll
students,
enjoy
staff, and faculty. Thank you for everything that you do. I just want to have a couple reminders for you
Actually,
today.
guys, I'm gonna
First
stop.
and most
This is
important out of all of them is wearing our mask. Make sure you wear your mask at all times. Also, make sure you are practicing safe social distancing. That means you're at least 6 feet apart from everyone. During lunch, during passing periods, make sure you also follow the safe social distancing guidelines. Again, we're trying to keep everybody safe and healthy. Make sure you are following directions. Students, make sure that you are bringing your devices and your chargers every day. Make sure you leave it charging overnight so that when you get here in the morning, your computer is fully charged. One last reminder is on washing our hands. Make sure that you wash your hands frequently throughout the day, or use hand sanitizer if washing your hands is not something that you can do all the time. Again, please make sure you follow directions. We are trying to keep everybody safe and healthy while we're here in person. And again, we are super happy that everybody's back, and we look forward to being with you here on Mondays and Tuesdays for this group. All right, after tomorrow, you will be doing distance learning, and we'll have a
it's
different
almost done
group
here,
on
guys.
campus.
Sorry, guys.
Thank you. Have a great day, Spartans.
Okay. So you guys, it'll always help if you guys kind of do it like some drawings. Remember, when we're thinking about gases, just do a balloon. So it gives us some conditions. It says, what volume would a sample of oxygen gas occupy at 2 atmospheres of pressure if 10 liters exerts a pressure of 1,140 torr? Well, let's say you're like maybe asking, Ms. Wilson, how could you already do those pictures from that? Let's just say that this is one thing you guys should recognize. You guys should recognize what factors are we talking about here. Notice it says volume, and notice it even says pressure. So right off the bat, we know it's volume and pressure. Let's say they didn't even say that. You guys should see ATM or torr. You should know, oh, those are pressure units. And then you guys should see L, liters, that's a volume unit. So we're talking about pressure and volume. So what should you guys do immediately? You're like, oh, I'm probably going to apply Boyles Law. So you do Boyles Law. Okay? So I got Boyles Law here. Now you guys, what you guys should do before you try to plug anything in, you should list what you know. P1, V1, P2, V2. Now look at how, let's assume we couldn't draw a picture yet. Let's just look at what we have here. Now you're just looking, it says, now notice it says what volume, okay? So we know a question mark's gonna be on our volume. And you guys, typically what you're gonna do is, you're gonna put that the second set. So you're gonna typically put your question mark in your second set. So now we need to figure out what pressure, what is P2 that corresponds to V2? What's the difficulty is that you have 2 pressure units. You got 2 atmospheres and you got 1,140 torr. The question is, which one of those goes with my unknown volume? If you read it, this is where, it's not necessarily super easy. You kind of have to read it and just make sense out of it. It says, what volume would a sample of oxygen gas occupy at 2 atmospheres? When you guys agree the unknown volume corresponds with 2 atmospheres, doesn't that seem reasonable? And then you just fill in, they're giving you conditions, and then look the way they say it. If 10 liters exerts a pressure of 1,140 torr, it should be quite evident that these two values go together. So V1 is 10 liters, and my P1 was 1,140 torr. Okay, so this is what you guys, and so maybe from this is where I can get a picture. So basically I have a situation where if I had my gas in a 10-liter container, it's going to exert 1,140 torr. But then what the question is, well, what volume would this gas have to be in order for it to exert 2 atmospheres of pressure? Now I'm hoping you guys would see at this point, there's something we got to do before we plug values in. There's something you guys should notice that looks kind of off. And what you should notice is our pressure units are in different units. What you have to first do is make sure units are in the same, factors are in the same units. So you're either going to convert ATM to torr or torr to ATM. You know what I always do? I always prefer to convert to ATM. So that's what I do. I can do either one. So what I would do is you have to use a conversion factor. Remember our conversion factor, which we showed you in a previous slide. 760 torr is equal to 1 atmosphere. So I have torr on top, so I'm going to put the 760 torr on the bottom, and I put 1 atmosphere on top. Notice that torrs cancel, and I'm left with atmosphere. So I'm going to go 1,140 divided by 760. Okay. Some of you guys were better at math. Maybe you could do that in your head. I can't. 1,140 divided by 760, and I'm going to get 1.5. It's 1.5 ATM. Now, you know what? One last thing before you guys plug it in, what I would like you guys to do is start to get in the habit of making a prediction before you actually punch your numbers. So if you think about it, 1,140 torr, it's actually the same thing as 1.5 ATM. 1.5 ATM. Now I'm saying at this point, there's something you should be able to predict about the new volume. You know, you think about it, guys. It was when it's in a 10-liter container, it's exerting a pressure of 1.5 atmospheres. What if now that the gas is exerting 2 atmospheres of pressure? What do you think you could say about the volume? Now, I'm not expecting people to just do in their head what the exact value is, but you should be able to say something about the volume. What do you guys think about it? Notice what happened to the pressure. The pressure went from 1.5 to 2. The pressure got greater. You guys, what's going to correspond with a greater pressure? A smaller or a larger volume? What's going to create greater pressure? If the volume gets, you guessed it, if it gets smaller. What kind of value am I expecting here? I better get a number here that's less than 10. If I get a number that's not less than 10, then that's probably an indication I did it wrong. This is where it's good to make an estimation or prediction ahead of time so it can kind of catch you if you perhaps did your calculations in error. So now you guys, I'm ready to punch values in. Oh, you know what? Before that, look, I'm solving for V2. So you know what? I'd rearrange this first. If I'm solving for V2, how do I get rid of P2? I divide both sides by P2. And then so V2 is P1, V1 over P2. So that's what I'm going to do. I'm going to go P1, which is 1.5 atmospheres, times V1, which is 10 liters, all over P2, which is 2 atmospheres. And that's going to equal to my new volume. Notice, look, ATMs cancel. This is why we had to make sure ATMs were in the same unit, so they cancel. 1.5 times 10 is 15. 15 divided by 2 is 7.5, and the unit is liters. What did I just figure out? For that gas to exert 2 atmospheres of pressure, the volume has to be reduced to 7.5 liters. And you guys see how this is consistent with what we expected with a reduction in volume. So you guys, these are the types of questions that you guys should be able to answer as a result of using Boyles Law. Thanks for hanging out with me. We're going to learn some new laws the next time we meet. We'll see you.